Welcome back to the All Sorts podcast. Sometimes we touch on topics that just demand a closer look. Remember those glimpses of Roman aqueducts? Water flowing uphill, almost magically.
Well, not quite uphill, but definitely defying geography in amazing ways.
Exactly, but those are just snippets. Today we're doing a proper deep dive. We're really getting into how these incredible structures were built, yes, but also how they fundamentally changed Roman life.
And their legacy, which is, frankly, still visible all around us.
We've pulled together quite a range of material for this one, detailed studies on politics and city life in Asia Minor, deep dives into specific marvels like the Segovia Aqueduct, plus insights from experts on Roman engineering itself.
So the goal is to give you the key takeaways, the surprising stuff, without you having to sift through, mountains of academic papers. A shortcut to the core story.
Let's start at the beginning then. Before these massive aqueducts, how did Roman cities actually get their water?
Well, it was much more basic, really. Think rainwater collection, cisterns and digging wells.
Yeah.
Pretty standard stuff for the ancient world.
So not large-scale, consistent supplies.
Generally, no. And while technically the Hellenistic Greeks before them had some of the necessary hydraulic knowledge, building big, especially above-ground aqueducts, was risky.
Risky how?
Politically unstable regions like Asia Minor often was before Roman dominance. An exposed channel or bridge. It's just too easy for an enemy to destroy it and cut off a city's water. Vulnerable.
Ah, okay. So enter the Pax Romana, that long period of Roman peace. That must have been a game changer for this kind of massive infrastructure project.
Absolutely fundamental. That stability meant you could invest in these long-term, often very visible above-ground structures without the constant fear they'd be torn down next year.
It provided the security needed for that kind of investment.
Precisely. And it's no coincidence that some of the earliest really significant Roman imperial involvement in aqueduct building pops up in places like Asia Minor during this time.
Like the ones you mentioned in the outline, Ephesus.
Exactly. The Aqua Julia, the Aqua Thricitica in Ephesus. You see involvement from emperors like Augustus and Tiberius, figures like Gaius Sextilius Pollio overseeing things. It really signals a shift towards these larger, more ambitious water projects.
No, this is where it gets really interesting for me. Aqueducts weren't just pipes, were they? Our sources suggest they were loaded with meaning. Gibbon, the historian, saw them as proof of Roman genius, right?
Yeah, that's a classic view. He saw them as a symbol of Rome's ability to sort of tame nature, impose order, a demonstration of power.
And other scholars picked up on that thread.
Oh, definitely. People like Sida von Reyden and Christian Wieland argue they were clear symbols of Roman political leadership across the empire. And Brent Shaw adds another layer. He suggests they represented a certain desirable Roman lifestyle.
How so?
Think public baths, fountains, readily available clean water. This was part of the package of urbanitas, Roman urban living, that elites in the provinces might aspire to. Having an aqueduct helped signal your city was part of that world.
So building one wasn't just practical engineering, it was almost like planting a flag, saying, Rome is here, civilization is here.
That's a great way to put it. Engelbert Winter even calls them cultural symbols that helped, standardize the look and feel of the Roman Empire. An aqueduct became almost a checklist item for a proper Roman city.
Which leads to the big question, who paid for all this? Was it emperors splashing cash everywhere?
Well, that's often the perception, isn't it? That emperors were the main drivers, building these as displays of imperial generosity and power. Winter certainly notes they were preferred objects of imperial welfare because they were so costly and visible.
And governors, too, presumably, acting for the emperor.
Right, they were traditionally seen as key figures in spreading this Roman model through infrastructure.
But the reality seems a bit more nuanced, based on what we've read.
It does. Emperors definitely played a role, no doubt, especially in really important administrative centers, the conventus cities or prestigious colonies they founded. But direct financial contribution across the board, maybe less than we think.
So what was their role then, more often?
Often it was more organizational, helping with the logistics, maybe providing access to military engineers or specialists, smoothing over legal issues, perhaps redirecting some funds. Think of Pliny the Younger when he was governor.
Right, his letters. He initiated projects but wasn't necessarily bankrolling them himself.
Exactly. The money wasn't usually coming straight from the imperial treasury or his own pocket for every project.
Okay, so if the emperor wasn't always paying, who was? Where did these enormous sums come from?
The evidence really points towards the cities themselves. They seem to have carried the main financial weight for building and expanding their own water systems.
Really? How do we know that?
Well, inscriptions often name the city as the entity responsible. It's interesting, Pliny complained about cities in Asia Minor being broke or mismanaging funds.
Yeah, the unfinished aqueducts and theaters.
Right. But the very fact that cities like Nicomedia or Nicaea could even attempt such massive, expensive projects, even if they ran into trouble, suggests they actually had significant financial capacity. Pliny often blamed corruption or mismanagement, not a fundamental lack of wealth.
Huh. That flips the script a bit. They weren't just passive recipients, they were active investors in their own infrastructure.
Precisely. And they managed it quite carefully, too. Cities regulated new constructions that used a lot of water, like baths. They kept track of who had private water connections. They knew water was precious and managed it accordingly.
Okay, so the cities are footing the bill, managing the system. Let's get back to the engineering. How do they actually work? The basic principle.
Simple elegance. Gravity. Find a water source, a spring, ideally for purity that's higher up than the city.
Springs were preferred?
Definitely. Cleaner, more reliable flow, usually. Then you just needed to build a channel, a conduit, with a very slight, very consistent downward slope all the way to the city.
Just sounds easy, but getting that slope right over miles must have been incredibly difficult.
Oh, absolutely. Precision surveying was key. Vitruvius, the famous Roman architect, recommended a minimum slope of, I think, 0.5%. But in reality, they often achieved much shallower gradients, maybe 0.15% to 0.3%.
How did they even measure that accurately?
They had some clever tools. The choribate was essentially a long wooden beam with legs and a channel for water on top of sophisticated spirit level. They also used things like the groma for right angles and the dioptra and libra for sighting and leveling over distances.
Incredible precision. Now, we picture those huge arched bridges, the Pont de Garde style, but you said most weren't like that.
That's right. The vast majority, probably over 80%, were actually underground channels.
Why underground?
Several advantages. Less material needed, less skilled labor compared to complex stone arches, and crucially, it protected the water from contamination and, from enemies.
Makes sense. What were these tunnels like?
Typically about 1 meter wide, maybe 2 meters high.
Right.
Big enough for workers to get in for construction and, importantly, for maintenance later on. They dig vertical shafts down from the surface every 50 meters or so per day.
What were they for? Access.
Exactly. Access during building, and then vital for maintenance crews to get down and clean out the channel later, especially removing mineral buildup.
So those iconic bridges, the arcades, were really just for crossing valleys or low ground.
Pretty much. They were spectacular solutions for specific problems, but not the standard method. The Pont du Gard is stunning, but it represents the exception, not the rule, due to the cost and complexity.
You mentioned water purity earlier. Did they do anything else to clean the water besides choosing clean sources?
Yes, they often incorporated settling tanks.
Yeah.
Castella is the Latin term. These were basically basins built into the line where the water could slow down.
Letting the gunk settle out.
Exactly. Sediment, impurities would sink to the bottom before the water flowed on towards the city. If they had to use a river, like the Anio for Rome, they might build settling basins near the intake, or even try to tap the river further upstream where it's cleaner.
Smart. Let's talk materials. What made these things last so long? Waterproofing must have been crucial.
Absolutely. They use a special waterproof mortar called opus signum to line the inside of the water channel. It's a mix of lime, sand, and crushed pottery or tile. Really effective stuff.
And the big structures like Pont du Gard, that wasn't mortar, was it?
No, that's precision stonework. Huge blocks of local limestone, some weighing several tons, cut so perfectly they fit together without needing mortar, held by gravity and their precise fit.
The labor involved. It boggles the mind.
It really does. The Pont du Gard has those 3 tiers reaching almost 50 meters high, 275 meters long at the top. It's astonishing.
Is that slight curve it has deliberate?
People used to think so, maybe for strength. But the current thinking is it's more likely due to the stone naturally expanding and contracting with temperature changes over centuries.
And the inside of the channel itself, the spatugas, what was that like?
They wanted it smooth, for flow, and durable. So it could be lined with dressed masonry, concrete, or that opus signum stucco. Sometimes they even added things like olive oil or maltha, a kind of natural asphalt or bitumen, possibly to improve impermeability or smoothness.
Okay, so the water arrives, clean and flowing smoothly, at the city edge. How did it get distributed within the city? Not everyone had pipes to their house, surely.
No, definitely not. The water typically flowed into a main distribution tank, another castellum, within the city walls. From there, a system of pipes, often lead pipes actually, branched out.
Lead. Wasn't that dangerous? We hear about lead poisoning.
It's a common concern, and Vitruvius himself warned against lead. But lead was abundant, easy to work with, low melting point. The risk might have been less severe than sometimes portrayed.
How so?
Well, two things mainly. First, the water in the aqueducts was constantly flowing, not sitting stagnant in the pipes, which reduces leaching. Second, Roman water was often quite hard, full of minerals.
Like limescale.
Exactly.
Yeah.
Calcium carbonate would quickly build up on the inside of the pipes, forming a protective layer between the lead and the water. That said, this buildup did mean the pipes needed regular cleaning to keep the water flowing properly.
So distribution was tiered. Where did the water go first?
Priority usually went to public fountains. Vitruvius emphasized ensuring a constant supply for the general populace. Then came the public baths, hugely important socially and hygienically. And finally, if there was enough water and you could pay the fee, you could get a private connection to your home or business.
Which brings us neatly to maintenance. You mentioned cleaning the pipes. What about the main aqueduct channel itself?
Oh, constant maintenance was absolutely vital. That same limescale, the calcium carbonate, would build up inside the main channel too, gradually restricting flow. So regular cleaning was essential.
How regular?
We have some fascinating evidence from the Devona Aqueduct in France. Studies there suggest it was cleaned roughly every 1 to 5 years, consistently, for almost a century.
Wow, that's dedication.
It is. And it matches recommendations made by Frontinus, the famous water commissioner, the curator Aquarum, in Rome. Keeping these systems running required serious organization and resources.
It really speaks to a stable society, doesn't it? Being able to maintain that kind of infrastructure over generations.
Absolutely. Look at the Segovia Aqueduct. It was damaged in the 10th century, but repaired and restored in the 15th and 16th, and parts of it were still delivering water into the 19th, maybe even 20th century. That's longevity.
So, summing up the impact, how did these aqueducts truly change Roman life?
It was transformative. Suddenly, cities had this huge quantity of reliable, clean water. It wasn't just for drinking. It fueled the whole culture of public bathing, allowed for elaborate fountains that decorated the city, improved sanitation with things like flushing latrines. It created a whole new level of urbanitas, sophisticated city living.
It became essential for a city's identity.
You could say that. Having a good water supply became almost a prerequisite for being considered a proper, thriving Roman city.
Right.
It boosted public health salubritas and added immensely to the beauty and prestige, the pulchritudo of the urban environment.
People must have been proud of them.
Immensely. We have writers like Libanios raving about the water system in Antioch. And there are even cases like Orchistos in Phrygia, possibly a village that argued it deserved city status because it had secured a good water supply via an aqueduct.
And the legacy today is undeniable.
Completely. You travel across Europe, North Africa, the Middle East, the former Roman territories, and you still see these incredible remnants. The Pont du Gard is a UNESCO World Heritage Site, a huge tourist draw.
Inspiring people for centuries.
Absolutely. Writers like Rousseau, Henry James, they wrote about the awe these structures inspired. And there are other stunning examples still standing. In Istanbul, Constantinople, Caesarea Maritima in Israel, Merida in Spain, they're powerful reminders.
It's truly incredible. The scale, the engineering skill, the sheer dedication over centuries. It really makes you think about the connection between ambition, practicality, and long-term vision. Delivering something as fundamental as clean water, but doing it with such, well, magnificence.
And how vital that infrastructure remains, even today.
Which is perhaps the enduring lesson. That commitment to providing fundamental resources, planned and executed with vision, has echoes that last millennia. What can we learn from that balance today? Something to ponder. And as we let those thoughts flow, we hope this deep dive has refreshed your curiosity. If you enjoyed journeying back to Roman times with us, why not share this exploration from the All Sorts podcast with others?
Please do. And if you haven't already, subscribe to the All Sorts podcast on YouTube. Help us grow our community of curious minds digging into history, science, and everything in between.
Don't stop here either. There's a whole reservoir of fascinating deep dives in our back catalog just waiting for you to explore. Dive in anytime.
And to keep the conversation going, find All Sorts podcast on X, Instagram, and Threads. We'd love to hear your thoughts and keep you updated on our next deep dive.
Thanks for joining us on this deep dive into the world of Roman aqueducts. Until next time.